In this example, we're asked to find the area of the inner loop of this limacon. The difficulty lies within finding your limits of integration. What angles will give you this area? I think it would be helpful to look at how this graph gets traced out step by step. So here I've set up a polar grid, and I want to show you that this radial line is at pi over 6, this one's pi over 4, pi over 3, 2 pi over 3, which is also 5 pi over 3. So as we look and see how we trace out that limacon, when theta is 0, we actually have negative 2, because as we're facing 0, we would go backwards. But let's see how this traces out. As we get to pi over 6, we have a negative r value. At pi over 4, still a negative r value. And we don't get to the pole until pi over 3. And as you come on along, at pi over 2, you're way up there. It keeps coming around, coming around, coming around. And then we get back to the pole at 5 pi over 3. Continue around. So what happens is that how can we get that area inside that loop? There's no one big continuous interval to give you the area of that loop. So you could go from 5 pi over 3 to 2 pi, and that would give you the top part, and then add it to 0 to pi over 3. That's one option. Another option is to take from 0 to pi over 3 and then double that. Always think about what your limits are. The easiest way I think to approach this is to go from 0 to pi over 3, which would give you this bottom half here, and then multiply that times 2. And so that is the approach we need to take. Or we need to divide it into two integrals and go from 0 to pi over 3, and then from 5 pi over 3 all the way to 2 pi. But I think that's quite cumbersome. I think it's much easier to use symmetry and approach the problem this way. So let's go ahead and reduce that out. And of course we have to square this. So we're going to get 4 minus, what's that going to be, 16 cosine theta plus 16 cosine squared theta d theta. Then we need to replace this with our identity. So we're going to have 4 minus 16 cosine theta plus 16 times 1 plus the cosine of 2 theta divided by 2. Then we can reduce this, make that 8. So we're going to have 4 minus 16 cosine theta plus 8 cosine 2 theta d theta. Remember, this 8 gets distributed to both of those. So I hope you can see that we can collect like terms and make that 12. All right, so I'm just going to kind of take a shortcut here and make that 12, and let's start integrating. So we have 12 theta, then the integral of cosine is sine, so we have minus 16 sine theta. Then here, because of the 2, we have to divide by 2, so we have the 8 times 1/2 times the sine of 2 theta, and that's going to be evaluated between 0 and pi over 3. So of course that's going to be 4. So we have 12 times pi over 3 minus 16 times the sine of pi over 3 plus 4 times the sine of 2 pi over 3. Remember, we're multiplying that angle times 2. Minus, then we're going to put in 0. So we're going to have 0 minus 16 times the sine of 0 plus 4 times the sine of 0. So again, all of that is 0. So what do we get from there? We have 4 pi. But then we got to do some trig right here. So we have 4 pi. The sine of pi over 3. What is the sine of pi over 3? That's the square root of 3 over 2 times our negative 16. So that's going to be minus 8 times the square root of 3. The sine of 2 pi over 3 is also the square root of 3 over 2 times the positive 4. It's going to be plus 2 square root of 3. So our final answer is 4 pi minus 6 times the square root of 3. So this one you just have to be very careful about your limits of integration. On this problem, we're asked to find the area that is shared by this chordioid and this circle. So before I tell you where that area is, I want you to pause the video and shade in on your paper what area we are talking about. So copy the picture, color it in with your pencil, what area is shared by the chordioid and the circle. Then unpause me and come back. Okay, so hopefully the part that you've shaded, you can kind of see that is light blue outlined. It's part of a circle, part of the chordioid, but that's the part that they've overlapped. Hopefully you can also see that it's perfectly symmetrical, that this side and this side are exactly the same. So if I can find the area of the region on the right, multiply it by 2, that would be the whole region. So let's talk about what that region would be. First of all, I kind of see this part. That's just a fourth of a circle. And I know what the radius of that circle is, right? And so I also have that part of the circle. That's another fourth of the circle. So that's just half of a circle. So the area of the half of the circle would be 1/2, because of the half of a circle, pi r squared. Well, r squared, that's 4/2, that's 2 pi. So that is the area of this. We didn't need to use any calculus. Well, that was pretty easy. But what about this other area? All right here. So again, this side and this side is the same, so if I can find one of those, then I'm okay. So here comes the hard part. What am I doing? Well, as I'm using the area between, if I draw out sectors, the function that I'm touching is not the circle, but it's the chordioid, where r equals 2 plus 2 sine theta. So as I am integrating, I have to integrate. My r would be 2 plus 2 sine theta squared d theta. And then, since I have 2 of them, I could multiply that times 2. The question is what are my limits? And that's the hard part about this problem. So let me do some erasing and say, okay, so how am I going to find the area of just this region? I need to know what are my limits to get there. So it looks like I need to know the value of that point, and I need to know the value of that point. Well, the good news is I know what the r values of those points. Here, r is 0 because I'm at the pole, and here, r is 2 because it intersects the circle. But I need to know what theta is. And I'm looking at on the chordioid. So I can set the chordioid equal to 0 and solve for theta. So I'd have 0 equals to 2 plus 2 sine theta, and that will hopefully help me get this point. I can also then say, when does r equal to 2, and solve for theta for this point. So why don't you, again, pause the video, try to solve those equations, and then when you're done, unpause and come back. Okay, so hopefully you should have gotten for this first one, when does the sine of theta equal to -1? Well, at 3 pi over 2. So this point could be the point when r is 0, theta is 3 pi over 2. What about on the next one? Again, you subtract 2, you divide by 2, and you say, okay, when does the sine of theta equal to 0? Well, at 0, pi, and so forth. Well, what's this point? When r is 2, theta is 0. Where's this? Way over here. R is 2, theta is pi. So that's that other point. Well, so I have my limits. I have 0 to 3 pi over 2. Does that really go in that order? Can I go from 0 to 3 pi over 2? Does that get me that? No. 0 to 3 pi over 2 would go from 0 all the way to 3 pi over 2 this way. And that's exactly what we don't want. So how could I go in the correct order? Meaning, how can I go from the pole, or to this point, out to there? So I'm rotating in that counterclockwise direction like we learned in trig. Can I rename theta? What's another name for 3 pi over 2 that's less than 0? Sure, negative pi over 2. So I can go from negative pi over 2 to 0, and that's going to go from here to there, going in that counterclockwise direction. Now I'm ready to integrate. So I can reduce those. That makes it easy. So my area is, so I have that sine squared theta again, so I have to use the identity of 1 minus the cosine of 2 theta over 2. I can reduce that, and I can distribute. I can collect like terms. 4 and 2 are 6. Okay, so now I'm going to integrate with respect to theta. So we have 6 theta plus 8 cosine theta. Here I need to be really careful. I have the minus 2 here, and then because of the 2 theta, I have to divide by 2 is sine. And what are my limits? From negative pi over 2 to 0. So if I put in 0, do I get 0 for everything? No, be careful. So let's just be really careful. So I have 6 times 0, yes, that's 0, plus 8 times the cosine of 0 is 1. Then I have minus the sine of 0 is 0. Then I need to subtract my bottom limit. So 6 times negative pi over 2 plus 8 times the cosine of negative pi over 2 is 0, minus the sine, let's see, the sine of, if I put in negative pi over 2 times 2, that would be negative pi. And what is the sine of negative pi? That's 0. So let's see, I've got 0, 0, 0, 0, but I've got an 8, I've got a minus and a minus, that's good, plus 3 pi. Is that my answer? No. That is just the area of the chordioid part. So your total area, remember, is the circle, which is 2 pi, plus this. It would be 8 plus 5 pi would be your final answer. So again, I stress the hard part about this problem is finding what area you're talking about and then your limits. And make sure your limits go from low to high and they go in the correct direction, that you're sweeping out that area from the pole and making sure that you're getting the area that you want.